Okay, so I am once again in the beautiful city of Valladolid in the north of Spain, and today we are going to Horses Research and Development Center, where I will hopefully see and show you how engines are tested, how they're fine-tuned, how the most extreme conditions on Earth in terms of altitude, temperature, humidity, how they're simulated in the Research and Development Center. If we're lucky, maybe we're even gonna get to the test track. They have a giant test track. We might see how some vehicles and prototypes are again tested, validated, fine-tuned. So I'm super excited. I'm gonna stop talking. We're gonna get going. Where are my damn keys?
Here we are talking about hybridization. So our hybrid product is called E-Tech. And this product is focused on CO2 and efficiency. So we developed this powertrain to get the most efficient powertrain. This vehicle is best-in-class CO2 with 105 grams per kilometer. And this is 20 grams above the other competitors. This powertrain is managed with this gearbox. This is automatic multi-mode gearbox. So there are no clutch, no synchronizer. Gears are synchronized with electrical engines and specific software that manage all the powertrain. So this software is always checking what is the best mode to get the most efficient behavior. So here you can see the main modes of functioning. We can be in 100% electrical mode. We can combine internal combustion with electrical, to add the power of both. We can be in 100% combustion, or we can be in regeneration mode, taking advantage of the kinetic energy and to get this energy to the battery.
Some noise, but not many. Not the same as a we work on. It's not manufacturing, it's preparing the product we are going to use.
What I want you is to introduce what we really do here in testing. So, in testing, this is our global life cycle. So we start with what we call testing strategy. So testing strategy is a team that it's in relationship with advanced engineering, it's in relationship with tuning guys, it's in relationship also with design guys in order to what? In order to anticipate what will be the next engine, the engines of the future, the technology of the future, the regulation of the future, and to translate that information into what kind of test cells will we need, what kind of methodology for testing the engines or the gearboxes or the batteries we will need, and also what amount of test cells will we need. And this is, if you come with me, this is just, for example, this is just one example of an air distributor of the intake manifold. This is the kind of work that we do. So this is just a sample, and behind that sample, there's all the documentation of what kind of thermocouple, where in the vein of air has to be placed, at what distance, and the same for temperature, for capture, for pressure sensors. So clearly we do this for all of the parts that we have to measure, and we transpose that to the client, so to design or to tuning, and also to the other testing services in Horse to be sure that we test everyone in the same way. That's very important, as we have several sites of testing. We want to be absolutely reproducible between all of them. Once we have the instrumentation, next point is to do the assembly of the engine either into the trolley, either into the vehicle. So for test engine, for engine dyno, we have this type of mounting. These are the standard trolleys with all the instrumentation that we've seen before done with representativity of the vibration, non-vibration harness of the powertrain into the vehicle. We have the same plot, the same vibration plot that we have in the vehicle, the same carburant circuit, the same cooling circuit. And in order to, we have also a system to engage or disengage the clutch in order if we want to run idle. And what's very important for us regarding productivity also is to do the coupling of the engine as soon as possible in the engine dyno in order not to lose time. So that's why we use this kind of plate, of a standard plate with quick connectors to do the mounting and the dismounting of the engine as soon as possible. So that allows us to take out and to put in a new engine in about 1 day, taking into account all the engine configuration also in the test cell. So this is our powertrain test cell. As all powertrains and all the engine dyno, we do have a machine to simulate the torque and the workload that we put into the engine and I would say the root condition and the excitation of the engine. In this case, we can excite the both sides of transmission. In this case, in this cell, we have the complete powertrain. We have the engine plus the real gearbox. So we attack the gearbox. It's the engine that attacks the gearbox, and afterward, the two transmissions of the gearbox go to this what we call flenders, the multiplicators of couple, simulating the wheels, I say. We have a few continuous fuel balance in order to measure the consumption, and you see all the instrumentation that we have to simulate vehicle, to simulate I would say cooling conditions in the vehicle mainly, and in the case of manual gearbox, we have also a robot to change the gearbox. It's not lately utilized because mainly we work with this hybrid gearbox, but in the case we'll have to develop a powertrain with a manual gearbox. We can simulate the gear speed, the gear shift, in this equipment. So, in this case, as you see, we are not using the real exhaust pipe, the exhaust line. We are using a simulating exhaust pipe. So what we do in this kind of activities is to manage the back pressure, to manage the value of the exhaust pressure, to simulate the real exhaust line comportment. And in the case we'll have to validate the vibration, the NVH of the complete line. There's enough space in the floor with this half-end profile, which are isolated from the rest of the surface to do the NVH validation of the exhaust line. This is what we call the control corridor. This is where all of our engine dyno are, both for reliability and for tuning. So, joking, I would say the difference between a reliability and a tuning one is that reliability have only 3 screens, and tuning has, on the other hand, 5, 6, 7, 8 screens. So why? Clearly because we have the engine control management control, we have the test cell control, we have the HORIBA mix analyzers control, the cylinder pressure control, and the complete facility control. So we can monitor, and we have to monitor with our client, with the tuning guys, these facilities. And as you see, the engine, the reliability one are much more simpler with only 3 screens, with the control of the engine in one hand, and with the engine control management in the other hand. Félix, ¿podemos entrar? So this is, I would say, a typical reliability engine dyno. And in this case, we have this possibility using the real vehicle intercooler, or we can simulate it also with these picker changers. So as you see here, we have 2, one for the turbo water, for turbo cooling, and the other one beneath is just for the engine, for the water engine cooling. Okay, and we also do the flow measurement of this water engine cooling.
Is this the
Yeah.
for oil temperature? No, for oil. Why is it heat in the
This is
oil
for,
cap?
This is for pressure.
For
This
pressure.
is pressure. Oil
You
pressure.
you take it here,
Yeah.
but you also take it probably somewhere.
In the carter, in the how would you say carter? In the
And the oil sump.
in the we take it also there, and we take it upside to know really what is the blow by pressure that it comes to the to the upper part of the engine. And what we enter when we enter the chassis dyno building, the first thing we see is a big parking lot. So, in order to do a repeatability test, what we need is the vehicle to be always in the same conditions. So that's why we have these soaking rooms. In these soaking rooms, we have several of them. We'll see later in the panel. But we can play with different temperatures. And what we search is to have the vehicles always in the same condition. When we say same conditions, what we mean is stabilize water temperature, stabilize fuel temperature, and stabilize oil temperature. That in one point, charge level always at the same point, and tire pressure always in the same values, in order to retire, I would say, uncertainty factors in the engine dyno when we're looking for emission.
I assume you're gonna be like drifting most of the time, right?
No, not with this car. So I'm a customer performance pilot for drivability, and my job is I'm in charge of the drivability of every HEV car for Horse. So I have to test all the cars and be sure that it works properly and no customer is going to complain about anything related to drivability.
So in my case, I am the drivability and also GRC quality specialist, and also I will be the expert of Horse in terms of GRC quality. My job is I work together with Jaime. We work to be sure that all of the requirements are okay. The GRC time is in a good point, and we have a lot of inputs from the car and from the driver, and we have to be sure that the car will be in the good level.
That car went there.
Mm-hmm.
Can we go on the oval track? No.
Yes, we can go on the
We can
oval
go.
track, of course.
Please. Well, this is a first for me.
Yeah?
Yeah, this a track like this. No, I've been to a normal track, but not like this.
We have two cars behind, we have to wait a bit.
Ooh, that was crazy. Wow. Hell.
Your first time is strange.
Oh
Yes,
my
it's
god. It's like you're in a barrel.
Yeah?
Wow.
Kind of.
And the camera went like this. Wow.
We can go up to 130 here.
Through the curves?
Yeah?
Yes.
Oh my god. This is crazy. Ah! Ugh. There's so much G.
Yeah?
Wow. It's like that one place on the Nürburgring, you know? The little
Yeah.
one, Carousel.
El carrusel.
Yes. For example, here you will see the electric machine torque.
Okay.
So now
So
you
when
can
I
start
release the
creeping.
brake,
As you can see, 30, 20 Newton meters.
and it goes up to 8-9 kilometers per hour.
So now I can modify, for example, I can multiply by 2 the creeping.
We have to be careful because all these strategies have a safety sibling, let's say,
Okay.
that is always looking at the main variable to check that everything is going well. If it doesn't go well, it has to block the car or do a reset.
So now we will see more or less the...
I'm gonna do
the
exactly
double.
the same. I'll only release the brake,
Yeah.
and you can feel more
Okay, it was
acceleration.
much more aggressive now.
Mm-hmm.
So
That's it.
can you modify that so that when you release the
Mhm.
pedal, it does a wheel spin? No, I'm
No, I
joking,
think
I'm just joking.
We could try.
I'm giving you bad ideas.
Maybe with a 2000 Newton meter, like if we
Can you try it?
Yes.
No, are you allowed to do this?
Yes, why not?
Okay.
If we don't do it, who will do it?
One
It's for
moment.
science.
No.
How much torque are you applying?
1,800. I want to copy to the level 1.
Okay, now
What's the peak torque of the car like?
at the wheel.
At
Yeah.
the wheel, 2,500 Newton meters, but at the wheel.
Okay,
Mhm.
that's still crazy.
So
Done?
one moment, I'm going to change to another screen. So
Are you
for
ready?
now,
Okay, wait a second.
Be
wait a second,
careful.
wait a second, okay,
it's
set.
going to be
Okay.
Okay, I'm ready.
120 Newton meters on the electric machine, the peak.
Maybe
Okay.
you have to extend it a bit.
Yes.
Up to 20 or something like this.
You're still trying it? Okay.
Yeah, why not? This is part of our job also. We have to check
You
the
must-
limits.
You must love your job. This is fun.
Not this, but sometimes we just have to test the limit and see
Yeah.
how far can we go, how much can we improve.
Yeah,
Because if we don't do it, nobody is going to do it.
true.
There's nobody more
Sure.
doing this. Done?
So now creeping will be until 15 kilometers hour.
Okay.
Okay,
One
take
moment.
Here we go.
But it really starts strong now.
Yes.
That was fun.
The problem is that if I release now the brake, it accelerates every time.
Ooh. Okay, so this is how you get a customer complaint.
Yeah, that's it. That's what you don't want. We can do the car clean the slope without touching the pedal also.
With creep, a high,
look at that.
with the high creeping,
Yeah.
you mean? Okay, we can try.
This is 30%.
30%, yeah. So here we have, in this case, we have two ECUs connected.
Okay.
One is the HCVC that controls the whole car, gearbox and both electrical engines and the ICE.
Okay.
And the other one is connected to the ICE.
Hmm.
So we can change the parameters of mostly everything.
Okay.
Okay?
And we have the possibility to modify something and goes back to the reference page. Reference page is the original calibration, and working page is all the values that I have put here, for example.
Okay.
So now I've released the brake.
We have the... okay.
No, it doesn't climb.
So with,
Okay.
with that creeping, it doesn't climb, but with
But we can do the car
now in working page another time.
a clean beam master.
That's it.
I'm not pressing the throttle.
Okay. Almost.
Maybe we need a
It's going. It's going.
There it goes.
Wow.
Come on.
Looking at the sky.
No, it's
Almost.
30 is too much.
Yeah. No, it doesn't want. Ooh.
Exhaust.
It's because I was in the back. No.
Nah,
Because we're
it's
heavy?
because
the-
we have
Ah,
a different exhaust.
Okay, for testing. I've seen.
Yeah.
it.
Yes.
My name is Javier Reyes. I'm responsible for customer performance. That means performance, acceleration, emissions, consumption, noise and vibration, dedicated to hybrid powertrains for Horse Spain, but also for Horse worldwide, because we are a worldwide company and we are developing projects for many countries and many continents.
Okay, so the question I wanted to ask you is mostly related to the new HR12 engine that is being developed for the plug-in hybrid drivetrain. And what I was wondering about is when we say we take an existing engine anatomy and we say there's this engine going into a hybrid drivetrain, and then we imagine the same engine in a non-hybrid application, so just only an internal combustion engine. Of these two scenarios, which engine has a harder life? Which engine has a harder duty?
I think a non-hybrid engine has a harder life, but also for statistics. So in a hybrid engine, the power combined makes the engine work less. You have electric traction phases in reality that allows engine to be shut off during many kilometers for a vehicle lifetime. So this means in a hybrid vehicle, you have, imagine 300,000 kilometers in where only 200,000 engine is on. So the same mileage in two vehicles, the hybrid one will have a healthier engine than the other one. Also, a hybrid engine is prepared to work in very specific RPM range and not normally in full power range if you don't request it. So you have less transitions of combustion, acceleration of the engine, deceleration of the engine. You work normally in a very specific RPM range, which is the most efficient one. So the less transitions, the less inertia to recover, to accelerate frictions. So also because of this, a hybrid engine will last more than a non-hybrid one.
Another question added to this. In a hybrid drivetrain, the engine is going to go on and off and on and off and on and off and on. Is this, and there's this sort of like a myth online saying that this makes it, worse for the engine, that it's constantly being shut on and off. Is this true or not?
I understand the question. Yes, it's normal that the people think about this because they think about old engines. But new engine cooling and also specific mechanical requirements have been increasing during the years, and now the metals, the alloys of the engine, the turbo is well prepared for this. We do thousands of kilometers for example, for full acceleration, full throttle, for thousands of hours, and we ensure the engine is going to be okay. Also, people is thinking about the turbo cooling or is going to be affected because shutting off and on. And this is completely studied. So the cooling of the turbo is kept even though the engine is off. Sometimes we have also the oiling of the turbo is kept. So the engine is not really off, it's sleeping, let's say. So everything is well designed.
And one more question. Let's say we have one engine, the same engine, HR12, in a internal combustion only vehicle. And then we want that engine to adapt it to a hybrid vehicle or a plug-in hybrid. What would you do? What is done to an engine to adapt it to a hybrid application?
The adaptation of an engine is not mainly hardware adaptation, it's control, logics and software. For example, HR12, it is really similar in a thermal vehicle than a hybrid vehicle, but the way it works changes a lot. First, we have only 4 gears in a hybrid engine, so RPM range, working range changes. And also, we have a starter generator, which is called HSG, that also boosts the engine when you accelerate, because it's directly linked to the crankshaft, and it's a double turbo, let's say, electrical turbo. So even though the engine could be the same performance, in real performance you have more because of electric assistance. And there's not so many changes, maybe some efficiency, some coating to improve efficiency of the engine, working in a Miller cycle instead of Otto, for example, could be due to the valve timing, but physically the engine is really, really similar. The big deal is control, logics, software. This is the difference that a hybrid powertrain makes.
One more question. You don't have to answer this one if you don't want to. What is your personal opinion, perspective? How do you see the current trends of evolution of engines and the future? What do you think about it? What do you feel about it?
I have some ideas, what I see every day. First, the hybrid vehicle is the new diesel, in my opinion. Especially, I will make some marketing. Our HR12 engine in a hybrid vehicle, it makes almost the same fuel efficiency as a diesel in highway, which is the hard point for hybrid vehicles, because in highway you don't have the potential of regeneration of battery and so on, but we have optimized efficiency so much. So in my opinion, diesel is not going to be missed, because we are developing very efficient engine in highway driving. For me, in the cities, there will be a mix between electric and hybrid vehicles. Not so clear if all PHEV or non-plug-in vehicles, but for me the trend is not going to be exclusively electric. I think it's proven that it's not a world valid option, only electric. I think hybrid powertrains has a lot to do in Europe, but if we think outside Europe, for example, our company is doing engines for many countries in South America, Africa, Asia. We don't have to think as an European worldwide. Worldwide, they continue with diesel, they continue with gasoline, they continue with many other options, and we don't have to forget that. We have to attend the necessity of every country, and we need to build a different portfolio of technologies, and this is the aim of our company.